this is structured. So you can see the design, display, assembly, if you have multiple components. And if you want to measure the volume, measurements, everything. And this is for 3D printing, there's a pair. So if you have a design or you just took a design from somewhere, for example, there are some scans, you can take an object and you just scan it and you can pull it inside the software. It can have some irregularities. So you can just repair it, fill the curves and gaps. And you can do some drawings, sheet metal tools they have, and also some visual rendering. So I'll just start from a very basic designing for somebody who's just starting from scratch, understanding this is very young people. So you can just simply play. For example, if you just want to create a cylinder. So coming back to how do you make a 3D object? So you just make a sketch in 2D. And from 2D, if you draw a circle and just pull it, it becomes a 3D, right? A cylinder. That's how simple they've designed it. So this is the sketch tools, as you can see here, sketch. It has line, rectangle, different kinds of, you can make different kinds of rectangles, circles. You can define different ways a circle. For example, this is a, you just pick a center and make a circle, or you can also do it by this way. This is 3-point circle. So you just choose one point on the circumference, the other point, and you can just say, you can see how you can define a circle in different way. This is a 3-point. So if you go back to your basic geometry, any 3 points is enough to define a circle, 3 points on a circumference. So this is one such way you can see how you can define it. But most of the times we use, try to make it simple, like just take it from the center one. So this is a simple circle. So once we have a circle, now let's see what we can do. So now sketch is done. Now this goes into this is all the 3D tools. So pull, you can just see it. You just make the cylinder, that's it. So any kind of a 3D starts with the 2D, whatever sketch you want, you just make the sketch and pull it. That's how simple this is. And move is a very similar tool. We will see how we can use it. So let's make the object even a little more complex. So something like this. And so I just made 2 rectangles and joined a line. And this is how it looks like. Let's see what we can do with this. So this is a 2D surface and it gives you a clear option which one to pull. It understands, okay, all of them are surface, let's pull each one. So you can just play with this. So you can see this is, and you can just keep doing it endlessly. So this is one of our structures. So in which all I did is made a surface and whichever direction I wanted, I just used the pull tool to pull it. So even now I just want to pull this surface this way in 3D, I can do it. So it's all up to your imagination. So this gives you a lot of flexibility for your creativity. So any kind of designs you can do. So for example, if you have an idea, say, there's even more little, I'll go into a little more details. Say you just want to pull the surface till this edge over here. So you don't have to keep, ballparking this, oh, should I do it this way? They have a tool. This is called up to. So this surface will be more up to edge or whichever point to choose. So to just click on this and click over here. That's it, done. Everything is in line now. So now say this surface has to be in this surface. They have to be a coplanar. Everything has to be seen. So just click on this surface and click the up to. Click over here, it comes. So now it all looks like little irregular. So you just want to make everything uniform, just click quickly and do it this way. Up to the surface should has to come all the way over here, up to, and this surface should come to the bottom, up to, this surface should come here, here, and this surface should come here. So you can see initially we started in a very abstract way, And now we are coming back into, it's almost done. It's like a complete body. And same thing, you can also go back reverse. If you want to reduce this, you just want to get rid of this, same thing up to, it understands, hey, it just wants to get rid of it. So anytime, see, we started from a very abstract way and we ended up somewhere. We ended up as a pure solid. And anytime you just want to go back, you can go over here, undo, or plus Control Z, which is the command for undo. So just start clicking here. And it has the history of it. It can just go anywhere you want. So this is the flexibility that tool offers you. So any kind of design you can do. For example, you want to have something like holding a stick or handle or something for cameras, a kind of a housing fixture to bolt it to a wall, you can design it. And I just took this abstract shape so you get a feel of what the tool could do, the potential of a tool. And next we'll go to the move. You can ask what the difference between move and pull. So pull is just takes a surface and moves in one direction. You can just see the arrow. You want to go up or down, you can do it. Add or subtract. That's what it does. And move is more interesting. So move is like, it does the same thing. So you choose the surface, you just click on this axis, you just move up or down. Same thing like pull. But it has also have something more to do. It can also change the, you can also move in the angles. You can also do it this way. So that is the beauty of it. So this is truly 3D now. So you can see how you can move in both the XY and YZ plane over here. So in that way, you can actually make something more not obvious to common man. That gives you a flexibility of doing things. So that's what Move can do. Move has even more potential. So I'll show you something else with Move. So for example, you just want to say, you just want to copy this. That would be a little advanced for now, but okay, I'll give you a better example of Move even better. So for example, you just made a design like this and you're like, okay, I can't manufacture this as one single part. I want to, make it as two separate parts come together. Some kind of this design you have. So we have something called combined split body. This is more interesting too. So you take the split body, you click on this, and we already have three different ones. So we already have three different, okay. Since we already have three different bodies, so for example, this is a body on its own. You can just move this, you can just move the surface. So this is how the parts will look like. So you can all bring it together. So as a combined body, it's like a puzzle. You can make a puzzle out of this, saying like, hey, this is a very awkward shape or something abstract shape in your creative mind you have. Now you would just want to separate each one of them. So you can start splitting the body, like say, for example, I want to split this body into two and select any plane. For example, I just want to split it from here. So now you can see it's a two different body now. So you can see it over here. This is a structure, tree structure. You can see which are these two bodies. So if you just do a triple click, 1, 2, 3, it shows is this body. So we'll just hide the other two ones. So this is how it looks like right now. And it's like kind of a puzzle you can do. So they are separate. You can just join them together. So in this way, you can make a design. So something you have in your mind, how the part, for example, like you want the camera to look like something camouflage, like a teddy bear or something. You make a teddy bear, and now you think, how should I dissect it? Break down into three different parts and then come together. So that's how you can manufacture. Like you want to put something, a camera inside a teddy bear, you want to keep it elsewhere. So you make a teddy bear and cut it into three different parts. Then you put a camera inside and bring it together. So all these could be helpful. For
What if you
example,
wanted to
like
duplicate the part?
You want to duplicate the part?
Yeah, how would you do that?
Oh, it's a good question. For example, like this is the one you want to duplicate it. You can use the
Yeah.
move again. So use the move, and all you have to do is like press the control and click on any axis. Press the control and do it. It's duplicated.
Oh, that's
So
cool.
yeah, so you can just make one design and keep duplicating it.
You press control, you said?
Yeah, you just do a
Okay.
control. I'll just duplicate this one again. Um, hold the control and click on an axis and just pull it. That's it.
Okay. That's cool.
So you can duplicate it, and you can also merge everything. For example, like this is the, so when you triple click on this, you select the entire body. You just do one click, you select the surface. For example, like you want to extend this surface. Let me hide this. Anytime you want to hide some body, just right click on it, hide, right click, hide. So for example, you just want to move this plane, move this surface, or rotate the surface, anything you want. And now you just want to, like merge two bodies or something.
Mm-hmm.
Take it here. So you can actually move this entire body on top of this like this. You can move it. And now you want to touch these two. You don't have to keep doing it for a long time. You just pull this, the ball over here, the cube. That's like the heart of the axis. So you just pull it to the edge. It understands what you want to do. And now you click on this one and up to, and you select the surface. Both of them are touching now. So
And
now,
how do you combine, like, how do you make the, how do you make that one part?
yeah, so you
Oh,
just,
okay.
yeah, I'll just show you now. You just completely select everything. You have a combine here, and
Okay.
they just combine together now. How do you know it's combined? Now do a triple click. Everything is selected. So if you want to split it again, no worries. Do a triple click, entire body, split body over here. And you can click any surface you want. So I just select the body and it says the saw, split it. And now you splitted it. So most times we use it, say, hey, some surfaces you don't just want to delete it, extra bodies, you can just delete it this way. Or you want to be more specific, then again, you select the body. For example, I just want to delete this surface and I click one to be this. So it just shows, the eraser shows which one you want to delete it. So I just deleted it. So you can combine, split, combine, you can do it endlessly here. So now it's again combined, I think. Let me check it out. No, it's not. You have three different bodies. Now we can combine it. So it's all combined as one now. So this is the overall. And one more interesting thing is, say, this one is just hanging out. I just want to split this body and I just reduce this one. So now I would just want to make a mirror image of this. I'll just even delete this one. You can also triple click and just click a delete. It just goes off. And I just want this surface to be here. Okay. So now I'm just trying to mirror it. Let me do a mirror. Select the mirror plane. I select this as mirror plane and enter object. That's it, done. So you kind of make anything a half section and you want to mirror that as both the surface. You can just simply go over here, mirror, and all it asks for which plane. What is the plane you want to mirror the object? Choose the plane you like. For example, I want to do it this way. Let me do it this way. Yeah. And so you can see a different kind of an object came. And now I just want to mirror this entire thing again. So select the mirror, select the plane. That's it, done. So you can see more abstract shapes, you can bring it down. So this is what mirror could do. And there's also one more interesting thing. There are some, like reform shapes like cylinder or something. So it's pretty straightforward. Cylinder is a circle with a height, that's all. So you just choose a point and choose the height and then the radius of it. So you can choose any kind of the cylinder you need. And next is also the sphere. Sphere is all you need is any equation you take for sphere, like surface area is 4 pi r squared, the radius square. So all you have to do is just select a point and just create a, a sphere. For example, I just want to select it from here. So you can do it this way. And now you want to make it hollow. Choose any plane you want to do it. You can go back to sketch. I select this plane, do a hollow here. And now you go to pull. Either you can make it solid or you can subtract it. Just take it backside. And now I just want to take it to this surface. So in that way, this is pretty solid. You can keep any kind of things inside. So you can do all such things. So this is the basic attributes. You can keep playing with this. What more we have? So, and you can change the color of it. For example, like you just want to change the color of this. So you go to a display from design. You finished the design now. Now let's go to the display. Oh, there's one more thing you can do. I'll show you the cross sections. So cross section is interesting. So you want to see what the part looks like from inside. You can see the cross section over here. And this is what you see over here is the viewpoint. So you can just change the view whichever way you like. And we have a plan view this way. It looks like, I'll keep it this way for now. So you can see the cross section. That is like how the part is inside. From outside it looks all beautiful, but how does it look inside? And then you see, oh my God, the part is like, it's very thin over here. I have to make it a little larger. Go back to pull again, and you just select the surface, and just pull it. Now it looks good, yeah. And now then you can just check through the cross section how it looks like throughout. So that's pretty much, you can select it over here or move it. It just understands it. So that's the basic thing. There's overall the design cross sections you could see. You can also see the cross section of this complex design. Let's see a cross section of here. This is how it looks like from inside. It's all solid here, and suddenly you see a gap. There's a gap inside. So it's like the hidden. From outside, it looks all solid, but I know when I made the design, there's a gap deep inside. So that you cannot see. That's why we always use the cross sections to see what's happening inside. Did they hide something? Do you have a space where you can hide things and keep like cameras and everything? So you can see some gap over here too. So this is a cross section is also a very important tool in 3D design to check the
How do you fill that gap if you wanted to?
Come again?
How, if the cavity you had inside the object, how would you fill it if you wanted to do it in like actual
Good
project?
question. So for example, let's see. You have a cavity inside, right? They have a very deep cavity inside. Okay. So what we will do is like, you want to fill it out. So let's take a pool and you can just select the surface. Then it just says what it looks like in 3D, right? You can see the yellow one. Just click on the surface. Now all you have to do is pull it. All you have to do is pull it. Then you can see it's getting filled out. That's it, done. So anytime you see a cavity or you want to create a cavity, you can do it the same way. So you can see now there's no cavity inside. You see the cavity just disappeared. So this is not a part of a cavity. This comes out in the design. No, that's also a part of cavity. So we'll fill it out too. So again, you select the surface, go to cross sections, and you just move it. This is where you can move the cross section plane. Let us see, wait for the cavity to come. They have a cavity here. So same thing, let's do the pool. This is going to be tricky. So if I choose the other plane? Let me choose another plane. Let me do it different way. So this is something called plane. Anytime you want to create a plane, if you can't select a surface, you want to create an independent plane, you can just create a plane like this. So this plane is like, it has no function. You can just see the plane here. You can use it for cross section or for making any drawings, you can do it. For example, like if I have to make a drawing in this plane, I just select the plane and I do a drawing. And I can pull it and, just to show you a different way of doing things. So let me take a cross section and select the button over here that moves it plane. And there's no cavity inside. Okay, that wasn't a cavity. That was actually this space, which I saw in a different angle. So right now there's no cavity inside this.
Mm-hmm.
There's also another way to look at this. So we can go into, let's go over here and see clearances. So clearance means a gap in the part. So it asks if there's any clearances, no areas found. Let's make a clearance and see if it says it. Let me, okay, let me take a cross section there. So once you make a circle, it appears as a surface. So you can just, surface, you can, okay. So now you can see the hole over here, the hole that I made it. So that's more than a clearance actually. It won't show up in a clearance, I guess. Now clearance is between two parts, okay. So right now the best way to see if you have any cavities, you do it inside. And if you want to fill the cavities, you can just go it here. And from the cross section, you can just use the pull tool and to fill out the cavity. That way we can do it. So I'll show you the display. For example, if you just want to choose different colors, if you just want to change the color, go to the colors over here and select if you want to change the entire body. So this is the fundamental, since tool is like, if you want to select a surface, one click. And if you want to select the entire body, triple click, 1, 2, 3. It just gets selected everything. Go to display. And now you just want to make it red. It's red. And if you want to make it yellow. And they have some colors, like these colors are like, from the palette. And you can change the opacity of it, say yellow. You can see kind of the transparency and everything inside. So you have, select a different one. And you don't want this, the transparency or translucent thing. You can just go over here and say, like, make it completely, this is the opacity, make it completely, no light can penetrate. Ouch. Let me check it out. Yeah, what happens. So yes, just select this, and if you want to see the inside of the parts, how it looks like, just reduce the opacity. You can see what's happening inside. If you, after seeing it, you know, that's another way to see what's inside. If you don't want to see anything inside, just make it completely, select the body and make it opacity to the extreme. Yeah. And these are some of the space clean colors that looks more realistic than, you know, the perfect yellow or something. Say this yellow looks a little different. This looks more like your plastic part or a metal part. This has some, so they have different colors for this. So if you just want to make different colors for different surface, just select the surface and say violet. Okay, it's just one entire body. Okay, then I have to remove it as a separate body. Let me split body. Yeah, so for one body, it just takes us one color. It doesn't let me do a different color. So we'll do it this way now. Select this and make it clean. Why is it not coming? Oh, okay, I have a different way. Now it should come. So you can just give different colors for different bodies. So once that is what a display tool does. You have some graphics tool. There's another way to see a design, a wireframe. And you can see what all, how many parts, complex parts you have inside. Let's look at this one. So you can see all kinds of complex ones in the wireframe. So if you have a shaded part, it's all 3D good. But if you just want to see a complex one, you can see. And this one is like the roller button. In between, you click it, you can see how it looks like inside, what kind of cavities you have for, you know, any kind of electronics to go inside, you can see. And hidden line, same thing. It's all part of the, this is just the skeleton of the part without any shading, how it looks like, hidden line removed. And if you want to see the hidden line, then it shows what is inside. So this is the wireframe. Next is, you also have a split to horizontal viewports. So for example, like you want to see it at different planes, you can see it. For example, you want to see the front side of the part and you want to see the back side, how it looks like. It's just like opening multiple tabs. They have this option. So you have two vertical ports, same thing, which way you want it. So let's say you have this part, you want to see the back side and front side. You can see it. That's why it's all just any kind of change you make, it happens on the both the sides. So say, make a rectangle. So you can see this way and both the ways you can see. That's what it does for display. And yeah, and then if you just want to, if you can talk, I think maximum you can do is 4 viewports. Same part, you can see it different ways. So in that way, you understand what's going on, and from then you can see the wireframe, everything. So, and now you just start off this one, go back to one viewport, go here. It is useful for sometimes when you make a complex design. Next is assembly. Assembly is an interesting tool. So any part you make, you have more than one part. So you can use the assembly in either way you need. Say, for example, you have this part. Let me just move this part. It's deep hidden inside. And say this part has to go over here. These two surfaces has to be in contact. Let's go to assembly and say align. just like the word says, it just says align and pick a plane. You can say it this way. And then you can say the move and hey, 90 degrees. So let me do it. Okay. So I would rather choose this one and say align. Yeah. So it just aligns like multiple parts you have. It starts aligning them. For example, you have this part and you want this part to be aligned to this surface. Just click the surface, align, pick a reference to align to, just say this one. And it just aligns these two surfaces, but you have to move around and play with it. And now you again say align. You can see how it aligns. And then you can just say these two surfaces, can they be, I think it's an angle, you can't do it. Okay, let me try line to this one. Yeah, because it's aligning. So these are different tools in which you can assemble it. And next is measuring. So if you just want to measure the part anytime, you can just click the measure. As the name says, what's the length of this? This is like 160 mm, 160.9 mm. And the area, perimeter, you can get everything. So you can get the circle diameter, 212, angle, perimeter. So any kind of surface you want to get the surface area, say here the area, you can get it. And you can also get the volume. So this is the volume I need. So mass property. Okay, you can get the volume here too from the mass properties. So all you have to do is like just click the body you want to have the volume or mass. So you can see the mass is density is like density equal to mass by volume. So the mass is calculated by density into volume. So volume you can get it from the software and it just multiplies the density. So I just click this body, the volume is 5514, so on, so a big number, which you can't, it's very complex to calculate in hand. So any kind of design you put, you can just click on the surface, say extract mass properties. It gives you the volume, center of volume. That's where the centroid of the body is. And you just multiply with the density. So if you can also input the density over here, it gives you the, and then you can get the moment of axis, since the moment of inertia, IXX, IYY, ICZ, all these things you can get it. It's, you must have studied it for sphere or cylinder, but this is more complex. So software helps you to get it right there. So this is more interesting, the volumes you can get it. And repair, these things are like more for 3D printing. So you don't need it right now. When you extract some bodies from outside, that's when you use the repair. And this is a nice one if you just want to make any kind of drawing or something. So for example, like you want to give somebody a drawing sheet. So for example, like say this is the body, this is the design you made. You go to a third-party manufacturer and ask him to, hey, you know what, I have a design like this. Can you just help me make make it out? He would like to have the part, but sometimes, the old-fashioned way. Right now, you just give him a 3D part, you do 3D print it, or you can machine it. But there are some suppliers or guys, manufacturing guys, they say, give me a drawing. So what you can do is go to File and a drawing sheet. So this is a very interactive drawing sheet. So you can see it just takes the 3D part and makes it into a 2D diagram. So that's a good thing. So anytime you just get lost like this, you could not align it, you have a plain view. So you just get it right here, and then you can start dimensioning everything, whatever you need. And so for example, I need this diameter, I need you know, the diameter of this sphere, I need the height of this, what more I need, yeah. So all you have to do is like dimension, click the surface or diameter you want. So I need the inner diameter, click it right here. Let me have it here. Dimension, yeah. So the radius is 93.07. So this gives you a pretty good understanding of like all the tolerance and everything. You can readjust these format and everything. So this is the just a brief overview of how you can do a design and create a drawing sheet attached with it. So, and based on this, like, yeah, I think this will give you a good overview for starting up. So any kind of design, you can start from here. Say, for example, if you're making a housing for this,
And Rohit, how about the material selection?
so material selection. So this gives this you can make a design, and material selection comes from. So I assume you guys are going for plastic. So you select the material based on what is the scope or what environment you're, there are many factors. So software, there's no point over here to choose the material. Once you do the analysis, like answers, when you do, that's when the material property comes in. But how do you choose the material? So you look at how it can be manufactured, which made cost. There are many factors: cost, manufacturability, and what is the environment in which it's going to function, the functionality. So for example, in your case, like it's just going to be a camera. Say it is sitting inside your home. It's just an ambient condition, it's a feel good. So you don't need an extreme material or anything. But so you want to have a much cheaper, you do not have a very expensive. So you go with a plastic that's manufacturable and also cheap. So PBT, PBT is polybutylene terephthalate. We call it a PBT material, and glass fill is 30%. That's a very common plastic. It's very easy to manufacture. And another material is nylon. Most of the clothes are made of nylon. That's also a very good material. But the nylon is a little expensive. Say PBT is like $2 a, like it's $1 a pound or $1.5 a pound. Nylon would be $4 a pound. It's like twice the cost, but still it's all, a pound is $4. If you're making few parts, it doesn't make a big difference. And PBT is more easy to manufacture because the plastic, you have to melt it and flow in this design. So this is the design. The plastic has to be melted and flowed in this. So PBT, you can easily flow it. The reason is the temperature at which you can flow is like 160 degrees Celsius. So it's easy to flow. Whereas if you see nylon, nylon requires 350 degrees Celsius to flow it. So, it will be a little difficult for the manufacturers to do it. But it's doable. We all have nylon and everything. So we stick with PBT. If not, we go for nylon. And one of the good things is, like, say you're going to put a camera in outside, like in Arizona, and so, desert in Utah mountains, where the temperature is always like above 100 outside, then it has to withstand a lot of heat. Then nylon is the best. But if it's the home and it's hardly exposed to, high temperatures, then PBT is good enough. So that's how we choose the material. I think in your case, it's going to be home. So you can stick with PBT. But if you keep it outside, see, that's a funny thing. If you keep it outside, there could be rain coming. It's right now raining in North Carolina. So PBTs are not best in rain. They absorb a lot of moisture and the part gets big. It's fluffy. Whereas inside the room, it's all good. Most of the stuff inside the room would be PBT. But outside, if a lot of moisture comes and it's very hot, nylon is better. So that's how we make a choice. Or there are some grades of PBT that's better functions in humidity and water exposure. So that's how we choose the material. So we make the design and then we see what environment, manufacturability, cost, then we choose the material based on it. Any questions, guys? In the software or anything else?
So one of the troubles I had yesterday, it was on it was a really simple thing, but I guess I did something wrong. So for example, I had a big square, or a big like 3D square,
Okay.
and a cube, and then I wanted to make a smaller cube like come out of it. But for some reason, every time I pulled, the big square would come out and not the small one.
Okay, I'll show you. Let me recreate it. So you have this square and now you try to make a smaller one on it, right?
Exactly. I wanted it to come out itself, the small one.
So say you just make a small one. And when you choose, it just comes the big one, right? That's what you choose, seeing it. So you don't see,
it takes the big one out.
you don't see this happening, right? This is what you need, and this is what you need, but instead the entire one is coming. Okay, you can do it this way. Sometimes what happens, that problems even happens to me. In this case, it formed a beautiful, square, but in case it doesn't, there is a way to do it, okay. So did you just choose the surface and just take the rectangle and do it like something like this?
Yeah, basically.
And you couldn't select this surface?
So when I tried pulling that small square, the big square came out instead of the small one. I don't know why I did that. I had to improvise and go from a different angle and make a whole new plane.
So sometimes the model could get corrupted. You have to try different ways, even very complex designs, I see it. So one way of doing is like, say, just make it. So if you make a complete, a closed loop, everything is connecting good. If you don't do it, if there's some gap here, you see, now you can't select it. Maybe something like this could have happened. So just check on the squares, like if everything has been closed loop. And then if that is not the case, just go back on this and just make a new line on top of which. And now it makes it. So that's one way of doing it. And there's another interesting tool. I think you have been using SpaceClaim for some time now. Let me. So let me draw a different one. Right now the body is very simple, so it's going to make a surface. What I was trying to do is like I was trying to use the fill. Fill is a more, okay, maybe I'll do it this way. Let me, yeah. And one more thing is like, do you know this, for example, like say, So whenever you want to do it like subtraction, so right now, so you just click on this and right click and you select the negative, that it always cuts, no matter in which direction you go. So use that way. And now you choose the active and you can cut it. And then you have the surface. I don't need the surface anymore, just delete it. So one more interesting thing is like, say you want to make a surface from here. What you can do is like, just click on this one, double click. Then it selects the entire one and use a fill. So what happened is it made a surface. Do you see this? So
Yeah.
if you have a very complex cavity, then you can do it this way. The reason like we do it this way is like, I can show you. And one more thing, do you know to make this as a new component and right click, move to a new component? So what this means is like, say like a body A. So after some time, you got to understand like, you just keep making a lot of bodies, then it understands everything are same. So what happens is if I don't make a body A, I'll just show you what happens is like, say, I want to have another body that comes over here, that mates here like this. And say, something like, say like it's a key that goes like this. And say this one would be display with something that, mates with the other one. So now say what will happen is if I just make this body bigger, did you see what happened?
Yeah.
Both become as one body. So this was right now I have two solid bodies and now I just want this to be like a key. So I'm just trying to pull it. So since both of them are like solid, when I pull it, oh, it understands, okay, from two it became one. Okay, it's a part of the same body. Let me make it as one. So you don't want that to happen, right? You want two bodies like a key. So what we do is like, that's when we just take this body and move to new component, say lock, say body A, and you have this body and you just move it to say move to new component, say key A. And now I'm just going to pull it up. It still remains as two separate bodies. So that thing you have to be, so you have so much bodies and any kind of, manipulation you do between them, they touch each other, they understand they are the one and they get combined. So when you move as a new bodies, then they understand, okay, they are different and we should maintain the independence between them. So say I just want to make a key even here. All I have to do is like click on the circumference, double click on it and fill. This is a trick, and you just choose the body and see right now I want to select the surface inside, but it doesn't let me do it. So I just hide it and it doesn't let me. Okay, then I'll do a cross section. And sometimes, yeah, cross sections are better. So now I'm going to do a pull, select the surface. You can see the surface and up to this one. And now you can see this body, display that. So it's like a key. And now I'm going to pull it from backside. And then I choose, okay, these two belong to the same body. So I can just drag this and put it under key A. So you can see these two. So when I just cover the key A, both of them goes off. So after you know how to design stuff, then you start, organizing in a structure. And now I just want to make everything as one single body. It's simple. Click on the surface and make a big square, or make it the same one. And pull it now. Pull it here. And this body is completely independent. Let me display it to there. And now I just take this and keep it under. So now you have 3 bodies in the key A. So you just select everything. And when you select, you press the control. Now you just combine it. So you can see it's one single body. So when you do a cross section, you can see how the keying happens. You can see the key is happening right here. They're meeting with each other. This is the key function. So you want to, okay, you see suddenly, hey, I want to do this. Just go to pull, click on the up to, click on the surface, it's done. So, and again, you can see the cross section, how they are functioning. And if you just want to see the key A, just hide the body A. You can see key A, how it does. This is the key A. This is a key that goes inside the other body. So it's kind of a play between the cross sections and up to. This is a very useful tool. Do you know how to use the sweep?
No, I've never used it.
Okay, sweep is straightforward, but it could be a little tricky if you, let me do this way. Let's say I want to make a sweep is mostly used for, something circular and a pattern you want to do it. Right now, I think you use mostly the, there are some instances when you want to make a groove or a pattern like S shape or H shape, you may need it. For example, let me show you something like this. So let me just turn it off. So there's one interesting thing I'll show you. Whenever you make a turns, we call it something like tangential. So this curve is tangential to here. That means like if you draw from the center, you draw a radius here. You can see it is like 90 degrees between them. So so if you see a distance between these two, it's 90 degrees. That's the tangential definition. And whenever the good design practice is, whenever you try to make a turn, try to make it tangential. There's a reason why I'm saying this, because like right now from here, none of them are tangential, but this is even more harsher. There's a sudden turn. And when you make such a sudden turn, the part would have some residual stress. That point is a discontinuity. So it can be a little weaker. So we try to make it as smooth as possible. Let me try to make this as smooth as possible. So even the softwares understand, like people like tangential. So now this is tangential. You see the sign over here. There's 2 green signs over here where I have the mouse. So that means tangential. And so even here there was, you can see the two green lines. That means it's tangential. So now everything is tangential. So it has a continuity. So that's a good design practice. So say you have a shape like this, and now you want to, make a solid block around this. So there are many ways to do. You have something called offset. Do a double click. You just get that wherever you want it, and now you just pull it. You see, So this could be something like you hold with your 4 fingers, something like this. And there's also another way to do this. So the another way to do is like a sweep. That's what I wanted to show. So for the sweep, whichever body you want, say, for that, okay. So now I just, whichever line or pattern in which you want to make a shape, just make it from 90 degree from that pattern and something like this. And let's say we put on some funny shapes. Okay. So imagine this shape. It's very hard for you to make it in just a solid bodies. That's why this is where the sweep comes in to help for you. So this is the sweep symbol. Like you say, like along the edge, whichever, this is my 2D pattern, and it says, hey, just sweep it through the pattern in which I say. So click on this, click the trajectory in what you want to do it, and double click. It just selects the entire sketch, the closed loop. And now you have this place symbol. This is very easy to just skip over. Ouch. Extruder is not producing. Let me see why. Why is it misbehaving? Pick a territory. Okay, let me make a change to it then. So this kind of shapes, let us slowly see what's happening. So you just sweep along this axis. Okay, I think this is where the problem comes into. Okay, and next we'll sweep along this one. This one, it finds it difficult. Okay. So you select the surface and click on this sweep, and then you select the trajectory, and then you click the full pull. And same thing, you select the face, sweep, and this full thing. Yeah. Okay, this was not matching here for some reason. So this shape, you couldn't be able to do it. So that's when the sweep comes into play. So when you want to make shapes like this, that is very more 3D, non-intuitive, counterintuitive for you. Just play. So far, just with the pull and move, that's more than enough for 95%. But if you want to make few more designs along a pattern like this, then it's very hard because you can't make the shape each. And because if it's a straight line, you can do this. But if it makes a right turn and all kinds of shady curves, it's hard to do. For example, the hanger you have that you put your shirt on, that's very hard to do with the solid blocks because it's circular, it has a lot of turns. Then that's when this comes into play. So sweep is a very interesting tool. So one thing that you should not forget is like, which I forget many times, is this symbol, the full pull. This we forget to click because, you know, back in the pull, you just have to play with it. But here it doesn't happen. So yeah, it happens here. Okay. Sometimes it doesn't happen. So don't forget to click on this one. Apart from this, I think, yeah, you can just see how you can pull this. Yeah. This is how you do a hanger. Hanger design cannot be done with the existing tools. You need sweep to do it. I think after doing the sweep and pull, you can do most of the designs. So nothing more. We have some designs called blend, but I'll show you. Blend, we hardly ever use the blend. So really need not worry about it. So for blend, you need two planes. You choose the plane and move it, click on the plane and say, so you select the plane, select the first plane, okay. Okay, we'll select these two planes, it'll be interesting. And I want to see. So say they select this plane, the top plane will make a shape. It goes in a different way. Let me just trim all these surfaces. So we have something like this. And let me make a, these are very sharp turns. You don't want to have a design like this. So make it little. Just trim it. This is sharp here, it's not tangential. But for now, it's okay. This is tangential here, it's smooth. And so you have a surface. Now let's make another sketch over here. So now let's make let's trim it off all the interfering bodies. So this is how it looks like. We'll make it a little smooth. Let's just turn it off. Something like this. Okay. So we have these two surfaces, and now we want to just connect this. Let's try by, if you try by pull, like you can just pull it this way. I want to connect it over here. From this, it has to go over here. So that's where the blend comes. I haven't used this in a long time. So let me select the faces. You can see I select the faces and the points. And I'm going to select these two. Did you see this?
Yeah.
Yeah. Blend, this is the blend symbol, and select the places. And select it. Yeah. So now you can hide the planes. So this is a true 3D shape. This cannot be done with the, so this, you know, sometimes if you see a mouse, a vertical mouse, we just hold it like this. I just gave an example. So this kind of shapes, you can't do it. It is manufacturable, but this is more counterintuitive. You can explore in the 3D. You don't have to limit within 2D, different planes and everything. So even if you see the planes I selected, everything is at an angle. So if you want to, and you can specifically design, some designs we do valley, we do it, say at 123 degrees. So now you create another surface from here and you can blend it. You can just keep on doing it all day. And so blend, select the surfaces and everything. Yeah, so let's say the blend and let's select these two surfaces. Now, yeah, okay, it still makes, but you can see it's like going like, yeah, just say that, okay, it is struggling. What happened? So that this is the basic idea, but blend is a very complex operation because within the 3D you can see how the part is being twisted and everything. So we don't use it very often, but it's a good thing. You can explore in the 3D space. Since you're making cameras and everything, you can just be more creative, put it in curvatures or add duct, HVAC in your home. You can put it in some angle and everything. So just you can play with your creativity. This is where it is. Blend. I haven't used the other one yet. Quick face. Yeah, these are tweaking things. But blend is an interesting tool. I think I just loaded too much stuff.
Did it freeze?
Okay. Any other questions you have? That's
So
yeah.
So are you a mechanical engineer? So is that what you do?
Yeah, I'm a mechanical engineer. Yep.
So what kind of stuff would you do like a normal day at work, like what would you do? Would you be assigned like a project and you like how do you know what to design? Like what kind of stuff do you do as a mechanical engineer?
I'll just show you something. Let's say PE. Let me show you something. So just look at this connector. You see this connector, right? Do you see my screen?
Yeah.
Yeah, so this is some of the stuffs we do. We design and everything. I design these stuffs. So if you see, this is you can just push it inside the yellow part over here. So this is some of the connectors we do. This is what it is, connectors and everything. So predominantly what I would do is like, I design connectors like this that goes into tractors and trucks and everything. So all those tractors and trucks that goes into, oh wait, I have a presentation. Let me see if I can pull it up. That's just a very generic presentation. Gives a good overview of what the vision is, so you understand. So yeah, this is there was an ANSYS conference. They recently had a virtual conference. So this is one such concepts in BMW. So what they do is like the future is right now we want to go fully autonomous, right?
Yeah.
So this is where we are right now. It used to be like we have it L0, L1, L2, L3, L4, L5. So I'm just speaking from the automotive industry. As a T is huge. They are in the data and devices, that is your mobile and commercial stuff, mobile Alexa. We do all those stuff too. We also do medical stuff, and we also do some automotive and trucks. So this is one such places where you can see L0, L1, L2, L3, L4, L5. What this means is like level 0 to level 5. So level 0 is just a driver, back in the 80s and 90s. And now it's like feet off. That is like you put adaptive cruise control or something. Cruise control, you don't put your feet off. That's like level 1. Like you have some kind of assistance. Before it was no assistance, and semi-automated. Semi-automated is hands-off. So hands-off is where we are right now. Not many cars we have as, like Tesla is hands-off. You don't have to just put where you want to go. It just drives it. So we are having a migration from L2. We are going to L3. That is highly automated. In highly automated, it's like you can just watch your mobile phones or something. You can look, he's watching in some videos. You don't have to put your eyes and completely, but you should still have, you should know what's happening. But with more safety, it's completely autonomous. You can put your mind off, then L5 you can sleep. You won't even have a steering wheel. So this is, as an industry, we are getting more autonomous,
So which stage is Tesla at right now? Like the best.
Tesla is at L2 and L3.
Uh-huh.
So right now Tesla is at L2, and
Yeah.
so from L2 they'll go to L3, and I'll show you where Tesla is at. Okay, that's a good question. I have another presentation that shows you. Okay, this is the kind of, so now you understand. Tesla is at L2. We are going to L3, L4. L5 is the most advanced. So this is where the Tesla is. So this is like followers, challengers, contenders, and leaders. The Tesla is the last one.
Really?
Yeah, but that is the car that's on the road right now, right? The Tesla is on the road right now, and this itself is a big thing. So they are pushed forward, and they are the only L2 cars we have right now. There's no one else. But in coming years, like in 2030 or 2025, we'll have more vehicles. Some of them are like Volvo, Toyota, Hyundai. Waymo belongs to Google. So they are working. They're working on like hardcore stuff down the lane. But as we go down, we'll get more of this stuff. Say like the question is like right now in 2020, it's mostly L0 and 1. You just have your adaptive cruise control. You can't even take your hands off, right?
Yeah.
This level 2 is very less Tesla, but as the year goes, you can see the level 2 is like blue. It just increases. So there'll be more cars like Tesla. And level 3 is like you can take your eyes off, completely your eyes off. That will come in 2030 in a big way. So in the next 5 years, you see a lot of L3. So L3 is eyes off. In 2025, you see, by the time you graduate from the college, you start working, you'll see a lot of eyes off car. So that's where we are. So as T is, we work in automotive industry and trucks. So we also, all these connectors go into eyes off. That's what Abbas and me are working together on, a lot of camera and everything. So all this stuff, kind of like, maybe I'll show you a better image. Wait, I'll show you another image that is better than this. Okay. So this is, I think I couldn't open that one. Okay, I'll show you this one maybe. So we have a lot of cameras, for example. My stuff is little misbehaving. Yeah. Yes, this is better. Yeah. So we have a lot of cameras now we are putting. So yeah. So for example, this is the cameras we'll be having. We put a lot of algorithms and everything that says, hey, is this a human? It says this is a human. And right now there's some kind of a human or dog or a car far away, which you can't see in a camera. So that's why this is a presentation where they show a thermal camera. So if you enter a barber shop or go to a dentist or something, they have a touchless temperature sensor to see what's your body temperature. It's all the thermal camera. So you see, this is a thermal camera that says how much heat your body emits. So
it spots a human better, or it spots an animal way faster than, I guess.
Yeah, and this gives a lot of contrast, especially. So the future is more of autonomous, and we put a lot of cameras, different kinds of cameras. So right now, Tesla has a lot of visible cameras. In future, they may have thermal cameras. So you cannot, if you see here in night, you can't see how many human beings are here, with cycles and everything. You can't even see there was a dog here. Did you see here?
No.
Can't even see. But the thermal camera gives you high contrast in a black and white because it
Mhm.
absorbs the heat emitted by each body. So this is the future. So as a TE, like what I do day to day, so some of my components go into these vehicles that help them achieve this dream. So they have a lot of components, and that's not easy that it just works one day, next day it doesn't work. It has to work on the car for next 20 to 30 years,
Uh-huh.
same performance. So that's a big challenge, right? And the way we drive, we take in a rain, we take in a desert, forest, we put a lot of sand, dust, water, put a vehicle in the water and drive. In all
Yeah.
these conditions, it has to perform the same way.
Mhm.
So that's where the real engineering comes, and what kind of material you choose, what kind of a design, reliability, even small things, very small things, 1 or 2 newtons force, it can play a big role in 20 years of life. So we do a lot of
Mhm.
testing, high rigorous testing to show, okay, at the end of 20 years, this will still be good. That's when people buy car. If you have to buy car every 5 years or all these things gets failed, there's no point. So that's where a lot of engineering goes. So you can see there's a sun, but actually you don't have all the glare and everything. You can see the end of
Yeah,
what.
you don't lose visibility with it.
Yeah. So that is what, my day-to-day job would be like something like um, designing connectors like this. Um, these are some terminal systems. Wait, I'll show what that is. Yes, a connector, something like this. These are some of the connectors you will be using that Abbas was mentioning. Some of the
Uh-huh.
connectors like this, all these connectors, it's very important because from a camera to, say you have a tab or a screen where you see what's going on outside, you need to have a cable, right? Sometimes it come wireless, but right now the technology is not there till wireless, so it's still wired. So you need to have a cable, and connector is the point where it's like a nervous system in your body. Your brain says to move your hand, and what moves your hand is the signal from the nerves, from the brain it goes. So
So do
we
you
are
work
the
on the
nerves. Yeah, go
do you
ahead.
work on the electrical version of that? Or are you like are you focused on just the design and then like someone like a electrical engineer comes and helps you with
Yeah,
more the electrical
exactly.
part?
Yeah, we have two engineers. We have one for mechanical and another one for electrical. So what we do is
Uh-huh.
like I do all the mechanical stuff, and because we have very high mechanically, I do for vibration. It's a very
Yeah.
high vibration, like 50 times of gravity or 150 times of gravity you see, and the part will just come off.
Uh-huh.
So I have to design in such a way, even at 150 times the gravitational force, it is still good, 150G, 100G. So that's my job. And temperature, even at 150 degrees Celsius, that is like the water at which water would be a steam. Water boils at 100 degrees Celsius. And this has
Yeah.
to perform even at 150. So it should not have any kind of contact. Small things can even make a big failure. If a part starts emitting some gas, it's all plastic, polymers. It can emit some gas at higher temperature. If it emits gas, it gets rust and will break down. So I should make sure nothing of that sort happens. And the
So like
electrical engineer comes like Abbas. He's an RF engineer, radio
uh,
frequency.
uh-huh.
So he says like, okay, what happens? How should we, give me more space to define? So we work hand to hand. We used to fight saying, hey, this is the best I could do. He says, no, give me more space. I can make it better. So we challenge
Mhm.
each other. So it's a team of electrical, mechanical, manufacturing engineer, a bunch of engineers we work together. That's
So
how
what
it.
influences your basic design? Like is it like your creativity that makes like see like the design on the top right, top left? Is that
So
like say you were designing that? Is that your just creativity, or are you told like, are you given an example and they just want it to be altered in a way, or like how
it's
exactly?
it's a good question. So most of the time, what happens is like um, we have it depends on project to project, but say for some it's a brand new project and nobody knows what they want. My customer's Tesla. He wants to put 10 cameras. He has 32 cameras in his car. He wants to put another 10 cameras for more safety reasons. And then
Mm-hmm.
he doesn't know how to do it. Then I would say have more space, right? Have more space for creativity. then I would go and design what I like. But if he says, no, I know what I need, this is all the space I have, and he gives me a lot of constraint, and this is exactly what I need. Say, for example, this is the shape. This is the shape he gave me. I wanted to keep it rectangle, keep it simple, do this. Okay. In that time, what happens is like, we know what, they already know what they want, so we just do it. But sometimes, you have 50-50%. Sometimes it's constrained that we just have to follow the design. We take an existing design, we reuse the design, copy it, and make some modifications from we call it a platform design. So for example, this is a platform which industry adapts. So you just don't want to deviate a lot. So, and if you just deviate, down the lane, it's difficult for the other future development. So we just have a platform and keep building on it. Just like your Microsoft Chrome or Firefox, they have a platform and they just keep doing an update. So sometimes a project comes like that, I just keep doing an update from an existing design. Sometimes it's brand new, a scratch, then you can apply your creativity either way you want. Some of them is like, this is an old design. This is very creative design indeed. This was done back in mid-90s. It's a very creative design. You have to slide it to lock on. It looks like simple, but these are the two parts. So you just mate both of them, and you just mate it, and it doesn't go inside. When you push this one, this gets mated up.
Like sin, basically.
Yeah. So this is all 3D, lot of latches and kind of a motion animation. Back in 90s, they didn't have all these softwares.
Yeah.
But the engineers were still able to do it. And this is still one of the very good designs. Like throughout, even in your car, you must be having all the trucks, buses, automotives, we have this design. So that is how the designs come out. If you have more space and if you're the first one to do, then you have more. But if something already established is, you just create on top of it. But more work, more fun would be on the analysis side. For example, like say for example, this is a connector. This is a simple thing which you put in your car. Okay, let's say this is the one. Yeah, what would be a better example? Yeah, say this is a chassis, as you can see. So what we do is like, this is a car's chassis or anything, a structure. What happens once you put a load? Or you make all beautiful designs, but the load is like, a person of 150 pounds or 200 pounds is going to sit. And 4 people sit at 600 pounds, and there'll be a lot of stress you can see, and it's going to break over here where the dead zone is coming. So this is also more fun. This is where the real fun, when you do the analysis, we clearly say at which point it's going to break. And then we would say, okay, increase the wall thickness, increase the thickness of the beam. So it's good enough. So here we have more fun. This is also more fun to do. And we do a similar analysis for vibrations too. So even though we just develop on an existing design, we have more fun doing these things. So this is a straight beam. This is a straight beam. This is what happens when you if you take a straight beam and just vibrate at 2000 Hertz, this is how the beam would look like. And your engine RPM is like 7,000 or 10,000 RPM, right?
Yeah.
There's so many shapes it takes. So beam would deflect like this. Imagine what would happen. The beam would break, right?
Yeah.
So entire chassis will come apart, like your car would be in pieces. So all the design we do is for vibration too. So it should not deform like this. So we make design thick enough that till the 7,000 or 4,000 frequency, it doesn't deform like this. So this is something more fun. So we have a lot of tools to do this. It's more colorful and more fun to do it. So this is all the different shapes it can take. So say this happens 1,000, 2,000, 3,000, 4,000, 5,000, 6,000. It can take all these shapes. So we do we select the material. Sometimes material selection could save us. So we select the material, the design. This is even a better one. We call it shape. shape 1, shape 2. So you can see at 61 hertz, it takes this shape. At 480 hertz, it takes this shape. 725, it's like a snake. 1000, it's so bad. So we have to make sure our design, like, these frequencies are pushed out. They call the natural frequencies. They resonate. So we just push it out in such a way like it doesn't fade. So
how does a concrete beam take up that shape? Wouldn't it like break right away since it's concrete, or is it something else?
So what happens is like this is a straight beam. So what happens is like when you vibrate it so fast. So
Okay.
this is every material, including. Do you have a blender?
A blender?
Yeah.
Yeah.
A blender.
Yeah.
So if you just notice the blender, when you switch it on, it just makes a lot of sound, like rocking sound. And when you switch it off, again, when it slows down, it makes a rocking sound and then it becomes smooth. Have you seen it? So if you observe it, even the fan or sometimes something is loose, when you start it on or switch on your car, dub, 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 then it, before switching off, dub, 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 it makes a lot of noise and comes down. Actually, what happens is like any body, including human body, every structure has a natural frequency. So what happens is like by the nature, the way in which the design is, if you give certain frequency, it'll absorb all the energy and it just start dancing. And this beam is that it has natural frequencies like natural frequency 1, 2, 3, 4, 5, 6, 7. And that's weird. So say at 61 hertz, it behaves. At 58 hertz, it does not behave like this. Till 60 hertz, it's all good. At 61, it starts behaving like this.
Yeah.
That's the vibration theory behind it. And if you go to the same thing at 480 hertz, till 470 hertz, it's all good. It's totally fine. But once it hits a 480, it takes this shape. That's kind of odd, but that's how the frequency. It's a completely non-linear thinking. That's why we find out these frequencies. These are the natural frequencies at which the body starts dancing, taking shapes. We call them mode shapes. So we just find out these frequencies, and what we do is like, hey, is there anything we make sure to avoid these frequencies. So if this body takes in 61 hertz, we make sure that, that component does not vibrate at 61 hertz. That component has to vibrate something beyond 61 or below 61. But if it vibrates at 61, it's done. That part will take apart. So that's the kind of thinking. And this is a very famous bridge. This happens a lot of bridge failure, suspension bridge failure.
I think Anirudh, with the camera project, rather than just seeing object of it or parts of the system, designing like a housing, a basic housing where you put the PCB inside of it, and then you create a perspective of where the camera is going to be mounted. And then if you like, you can support them on the connector side also, and then
I can support them on the design side if he starts on it. Yeah.
And then maybe have it on a vibration shaker and to say, okay, so, even you can even have it in the car and, plug it to a power supply in the car, and they can test it after a month and to see. But I think like he was asking Mushtaba about the project, what do you do? Is to give them something that's very close to, the real world, or it will be automotive Ethernet, which you can apply to industrial, you can apply to other aspects of transportation, not just automotive.
Yeah.
That will give them a pretty good idea. And it's a system that they can visually see a camera display of the camera and say, oh, okay, for Ethernet, I give you I'm not sure if you know when it does the compression, it tends to heat up. So if we have to put a fan on top of the module, that will be another interesting project where we get a over-the-shelf fan and see how it can be attached. And then I'll give that project to Mushtaba with your support, and he can mount it to some plastic where, oh, okay, great. Now I got the whole system being cooled. And I'm not, do you use ANSYS Ice Wave or Ice?
Ice pack.
Yeah.
I used to use before, but yeah, I can work on it.
Yep. That will be giving them a good idea in terms of heat and then vibration. Then they're almost like in the park, you know. Not a lot of intern students go that deep into the project, but that's the objective, is to get them in the ballpark.
So I'm just trying to show him what it happens when it's heated inside an electronic enclosure. So something like this, Mutima, like, you know, if it's pretty much heated, we keep a fan and everything. And thermal CFD, we call it the thermal CFD. CFD is computational fluid dynamics. Yeah, this is even a better picture. Let me get you. Yeah, this is better. So this is what happens. You have two fans over here. So it's just pulling the air, and you can see the green lines are how the air is moving. So what happens is, like, you see all these red lines over here?
Yeah.
So these all are like to the PCB. You have all the capacitors, insulation, processors, and everything. They get heated up. Right now in your computer, as we speak, it's getting heated up. So there is a life. So any laptop you buy, you want it at least to last for 4 to 5 years, right?
Yeah.
So the life is directly proportional to the temperature inside the enclosure. So if you have a camera system, and it has to be like, there are some limits, standards, like the temperature inside this enclosure has to be less than, say, 50 degrees Celsius or 60 degrees Celsius, something like that. It should be, but most of the time it gets so heated, you can just put your hand, you can feel it's like steam is coming, 100 or something. So what happens is, as the temperature increases, say a laptop has to work for 5 years, will work only for 1 year. The life is drastically reduced if the temperature is hot for a long time. That's why we put a fan, or we ask them to switch off your laptop because it gets heated up, overall life decreases. So that's what Abbas is saying, like, you know, you kind of put a heat sink, reduce the cooling. One of them is like putting fins or fans to reduce the temperature. So first we make the design. So this is also part of mechanical stuff. And so we make all the design, we assemble all the electronic packaging, we call it, because we're packing the electronics inside. Then we understand how much heat, because each one will give so much heat. All this heat, when you just add some and just multiply inside, it'd be so hot. So now we have to think ways of cooling it. Like, should we do a liquid cooling, or should we just do a natural cooling by air? Forced cooling, we call this as forced cooling. Battery packs in a car, Tesla's battery packs, it's very heated up. We do a lot of liquid cooling over there. Right now in your car has a liquid cooling for the engine. So that's all the thermal side of it. So this is how we work hand to hand with electrical engineers, mechanical. This is the process that goes. So a lot of interesting areas to look into. This is how my job would be. End product could look like very small, but behind that small product, so much work goes inside. That's why it was 20, 25 years.
Yeah, and I think the good thing is we'll put them through a real project rather than just an assignment.
Yeah.
Where the software engineer, he will have to take like the laser, he will have to take the image, the sensor, stack them up on top of each other, and then run an algorithm, a sweep at the same second, and then figure out where is that object, what it is, and what the ECU needs to do. Versus the mechanical engineer, they have to worry about heat and structural foundation of the PCB and keeping it cool. And then, you know. Thanks a lot, Anirudh. I have one other engineer from, actually from France. He will be joining at 3 o'clock for hardware and other stuff that we need to talk about. This very good information. I will cut sections of this meeting out, some of it, and then publish I would say the bread and butter of it.
Okay, sounds good. Thank you guys. All the best.
Thank you for the intro, the presentation. It helped me a lot.
Okay, anytime. Take care.
you.
Bye-bye.
Awesome.
Contact
Goodbye.
information once I run it by you, and then they will reach out to you.
Yeah, you feel free to contact me anytime. Abbas can share the information, my email. We can speak later on too.
Sounds good.
Sounds good.
Yep.
Thank you.
Thanks, guys.
And then Anirudh, I will show you there's ways to, at zero cost for you, there's ways to support the Michigan FC organization and youth through the TE Foundation, which I will show you how to go in there, and by just simply taking 5 or so minutes, there's ways that we can get capital, and then we can actually start, instead of having a dummy unit just testing it RF-wise, we can bring the processor and the rest of the life into the whole project rather than just a connector with a trace.
Okay, sure.
I think that you will like it too, because it's like, oh, okay, instead of just saying this connector does 1, 2, 3, they actually see it in their own eyes, feeding whether it's a laser or a sensor or a camera image into the screen. Then they can say, oh, wow, this is a good system. And a aged cable and aged a connector that has gone through so many cycles of testing and is still able to feed good data back.
Okay. Yeah, sounds like a plan. Yep.
Thanks a lot. I will reach out to you also, Anirudh, maybe a manufacturing engineer that you know, or another engineer that they can maybe take 1 hour every 3-4 months to give a perspective of, okay, here's a design. Can I over mold this? Can I, what would it take inside the molding cavity?
Mm-hmm. Yeah, I can ask some people over here. They'll be very happy to do it.
Great. Thanks a lot.
Anytime. Thank you, guys.
Take care, Mustafa. Take care, Anirudh.
Yeah, take care. Bye-bye.
Bye-bye. Thank you.